Hi, and welcome back to the next video. This video won't be about plants, it will be about how I design a lamp for my son. The story is quickly told. My son came to me, he moved out and lives in the dorm of the university, and he came back and said he needs a second light source. Now the idea that we came up with is an indirect light source that projects light against the wall, standing in the corner, and it should have a very slender filigree design so that it doesn't take up too much room. And this is what this video will be about. Now, in my delulu of grandeur, I told him, boy, I'm not gonna buy you a lamp, I'm going to print one for you. And and this is what we're going to do now. We're going to design a lamp, and we're going to print it, and we're going to assemble it, and we're going to test it. Now, the idea is to have a triangular base. I draw it like, well, first off, let's draw the room. It's something like this. So here's a corner of the room. That's a wall. That's also a wall. And the lamp should stand in here like this. That's a little 3D design. It has a triangular base shape, so these 3 points is basically where it will stand. And then it extends upward roughly 120 meters. This should be roughly 40 centimeters. This will be also 40 centimeters. And the light source will be an LED strip, an RGB LED strip that is built in or pressed into here, and it projects light into this direction onto the wall. Now, in an optimal world, the RGB strip has different programs, different lighting colors, white, yellow, pink, whatever the boy is in the mood for. And this is the idea basically. Now, I've talked before about the conditions of the Bamboula printer, or the obstacles that we have is that the build plate, the print plate is 25 by 25.6 centimeters. That's fine. So this means that if this side is 40, we need to create a segment here. So that's the idea, to create a base part. Then to create the feet, the extensible feet. Then to create multiple segments which go up and which hold a LED strip. 1, 2, 3, and however how many these are. And so additionally, I also wanted to keep it slender. It shouldn't take up too much space in the room. And let's see what we can design here. So let's start first off with the base. This is the final product, and my approach here is not to redesign everything from scratch, but to take a look at all the steps that I took to get to this final design decision. So that's the base part. The extensions are the legs, and what goes upwards is of course where the segments go in and the LED strip goes in. So first off, I started off with basic geometrical shapes. So in the middle is the placeholder for the LED strip, and the extensions on to the left and to the right are of course the feet. Now, once I've extruded everything to a reasonable height, so the idea here was for the feet to be nice cubish, and the holder for the clamp and for the RGB LED strip should be quite high so that it has enough space to give it a firm stance. Now, SolidWorks lets you combine parts with each other. Either they will be solidified into each other, or you can subtract them. And this is how I did it for the cable from the LED strip, so that I can lead the cable through here so that I can connect it to the wall socket. Once that has been done, I started rounding the edges. It should of course feel nice to the touch, No one should hurt themselves if they stub their toes against it. I mean, it would go anyway flying because it's so light, but it's still, when you print 3D plastics, the edges can feel really hard, and I thought I needed to soften them. Now in this step I am creating a hole where the clamp and the segments that move upwards will go in. Once again, it's a simple subtraction. And then I've created the extensions for the legs where the second leg parts can be pulled over and combined with the base part. And the idea here was not to glue, not to screw, but just creating tolerances that it sticks very well together. Of course, I've duplicated this on the other side as well. I've extended it to 3 centimeters. This should be more than enough to keep the two parts together, the feet and the base. One thing when you're working with 3D prints is if you combine two parts by pulling one part into the other one, it's always a good practice to round the edges of the part that goes into the other one. Why? Because it makes sliding it in so much nicer than having these really hard 90-degree angles. And then last but not least, I've created the space for the RGB strip to completely go down, for the cable to go through the hole I've initially created, and that's a simple subtraction once again. It's really nice to create designs based on parametric attributes. It keeps running everything tidy and fancy. Yeah, and there I gave it a little floor, so I've extruded it upwards so it doesn't go into nothing from above, but it still has some ground on it. Now with that out of the way, it is of course time to do a lot of prototypes. Since I'm new to 3D printing, I need to check whether or not my tolerances and everything that I've thought of during the design process is also correct. I've printed a prototype here, so you can see it. It has the triangular shape, it has the hole for the cables, and yeah, the print came out amazingly. It's so cool and so nice to see how the Bambu Lab printers work out of the box without any hassle. You can throw anything at them and it is lovely. If we move on to the feet, to the second part, this was a fairly easy part to do. You simply just create a rectangle and you extrude it upwards for the same height it has on the base. So once again, working with exact measures is a perfect way to create really nice things. The feet should be roughly 40 centimeters, as I said, so giving here 20 centimeters to the base, we are around 30 something centimeters altogether for the base. Now extruding it upwards, perfectly fine, and then starting off by creating a hole for the base to slide in. Once again, perfect measurements. And the idea here is to not use the same measurements as the extrusion of the base has, but to give it a 0.1 millimeters of tolerance that enables the base part to slide into this hole here, and then simply just give it some edges. So it's once again, the design is similar to the base part, everything flows into one another, and yeah, that's it basically. So, and last but not least, I give my models always some stamping. So you can see here I have added some text and engraved the text into this part. only on just one foot piece basically, and it says my initials, the L01 for lamp first design, and the .25 for the year I've designed it and I've printed it. I've also printed out the feet extension in a smaller form so that I don't waste too much filament, and as you can see, it fits perfectly on it. Nothing is loose. I have even a hard time pulling it off or putting it on. So all my measurements and everything have been quite well designed. Now moving on to the segments or to the holders, placeholders for the RGB LED strip, I had quite a few designs and design iterations to come up with this solution here, what you can see here. The idea was, okay, you need to put them together, slide one on top of the other one, and while it worked quite well, I've always had the feeling it doesn't hold really. So this is the idea I came up with. So we have a segment that is 20 centimeters long and extends downwards with a little nose, I would call it, that can slip into the other segment. So there were a lot of basic geometrical shapes that enabled me to do so. I know from measuring the LED strip that it is 5 millimeters wide. So once again, you need to work with tolerances here. So I put the hole or the rail for the LED strip at 5.5 millimeters. Now, then I've extruded the bottom part, which will slide into the other part, of course, gave it some roundings, and created a hole where the nose will slide in. So you can see it, the tolerances are really on the 0.1 millimeters, and they will slide in really neatly, and it's very hard to press them on. But this design ensures that it doesn't move on either axis if they are slid into each other. So it doesn't move forward, backward, or to the left or to the right, because it is holding it quite firmly, as you will see later on during the assembly. But one thing that is really important to take away here is that, hey, please pay attention to the tolerances. Please do some prototyping if you are doing projects like this, because it saves you so much time. When it comes to the segments, I've also created two smaller prototypes. So you can see here, come on, focus camera. Here is the space where the LED strip is going in. Here is a little hole. Come on, focus, not on me, focus on the part. Oh my. And it goes in really nicely. It's very snug, and the concept works very well. Now, of course, I've printed on the clamp and the top as well, verified the prototype, verified the design, and now we can move on to the assembly. So, before we can assemble the whole lamp, let's put these aside because we don't need it. And you can see that the bill of materials is a base, 6 20 centimeter long, well, I don't know how to call it, but the LED strip comes in here, so you can really start assembling them. So I made here a little hole so that these fit together, and if I put them in, then it's done. So we repeat this 6 times, and you can already see how perfectly it fits together. Of course, there are nudges, but this is something we have to live with. And just put everything together. You can see that the tolerances are really nicely. It's heavy to put it there, but this also means that it's more sturdy, and I can wiggle it and nothing breaks, nothing creaks. So let's bring in the last one, and with the 6 20cm segments we have something that will be 120 meters high, 1 meter 20 centimeters high. So now that this is done, we can assemble the base. So we put the foot on here like this, we put the foot on here like that, and you can see how this all comes together. Now we have also a cap for the top, and we have a clamp that comes in here and that holds the base and this part together. So now we can quickly assemble the lamp, put the LED stripe in there. Usually I get help from my wife, but she's currently doing the camera work. And as you can see, we do not need to glue, we do not need to screw. The tolerances, as it has been designed, are made in a way that this light strip is holding itself. So we know that the LED strip has a width of 5 millimeters down here, so the whole thing was designed to hold 5.5 millimeters. The clamp goes on in here, but first let's create the top. This is just, once again, slide it in here, and it hides beautifully the end piece. By the way, this is a regular LED strip for €9. It's not really that expensive, but it does the job. So for the base, I've created here a hole so that the cable management can run through, and just like this, and we can simply press this on here, and now the lamp is assembled. And how this looks like, it's a very nice design because it stays very straight, it doesn't fall over, and it works perfectly. Now in addition, so you can see the segments, that's fine, but you can't see any holes down here. And also if we move up a little bit, you can see that the top is closing everything. So, and this is how it was designed. It should stand in the corner and it should illuminate the corner. So this is a lamp. My son has moved out of the apartment and he wanted to have an indirect light for his dorm room, so to say. And it stands alone. We can put it a little bit more far from the wall. It has a nice remote control. And this is how it will look like. I hope it goes well on the camera. And it has different programs, but we can also turn it off. And it has a nice animation, turn off animation and a turn on animation. So, super. I hope my son has lots of fun with this. And if you would like to have the CAD files, the step files, just drop me a line. Thank you very much for watching. See you next time.